Hi, I am Ben Solomon. Today is November 24th, 2021, the eve of Thanksgiving. This video I'm going to talk about is about global warming. Okay, now we see it's titled, What Didn't They Want You to Know? The objective of this video, of this presentation, is to explain why global warming is due to deforestation and not emissions of CO2. Done it in a manner that you can verify the facts on your own. One more piece before we start this. This is a sample. This is an example of where the metering stations are. In this map, taken from Berkeley Earth Surface Temperature Study, it shows the air pollution stations. The carbon dioxide stations are similarly positioned. And you can see that the bulk of these stations are in highly populated areas, Europe, USA, China, India, and the heavily populated portions of Australia. And most of Africa and Latin America and Russia do not have stations to monitor climate change. There are currently 39,000 unique stations with a total of 1.6 billion temperature reports. So it's an extensive amount of data that we have. One station I want to point out is Mauna Loa Station, which is in Hawaii. It's administered by the National Oceanic and Administration, National Oceanic Atmospheric Administration. And this is the record we will use to measure global temperature change, simply because it's surrounded by the Pacific Ocean, miles and miles of Pacific Ocean, and you do not have these high density population areas biasing the carbon dioxide levels upwards. So global warming is real. Is emission CO2 based global warming true? If we have no one statistics, is called one metric, it's called temperature anomaly. What happens is when people measure climate change, they have a reference temperature, which is maybe from 1950 to 1980, maybe from 1970 to 1990. And you have to know what your reference temperature is. And then you take whatever temperature you're measuring it minus that reference temperature, and you have the temperature anomaly. If it's for the whole world, then it's termed global temperature anomaly. So if you plot the graph, the data is from the World Bank, and NOAA is Mauna Loa Station. And these are the web links. You can always pick up the data from these web links yourself. And when you plot the graph, see here you have by year from 1960 to 2020. On the left side, you have emissions CO2 in kilotons, millions of kilotons. On the right side, you have the global land and ocean temperature anomalies, which is 0 here, and it's If it's lower than the reference temperature, you have minus. If it's greater than the reference temperature, you have plus. So when you plot these two on the same graph, you see that the blue dots are the emission CO2 in millions of kilotons, and the orange dots are the temperature anomalies. And you look at them and you say, oh yeah, they are correlated, very correlated. And so, yes, emissions CO2 is the source of global warming. And then you look at the European climate disaster. But at least our climate change scientists say that when the temperature anomaly exceeds 1.5 degrees centigrade, there is supposed to be a climate disaster. Well, Europe, if you look at the global temperature from 1850 to 2018, see down here, you see that the reference is 1951 to 1980. And here again, it's the same reference. So you see this temperature rising from about 1920s onwards. The global temperature is, temperature anomaly is about 1 degree. It reached 1 degree, now it's closer to 0.8 degrees centigrade. Whereas if you look at the European temperature anomaly, it's more or less flat here, and then around 1980, it jumps up and it goes to well above 2 degrees centigrade. Let's say it's about 2.3 degrees centigrade. So Europe has exceeded the 1.5 degree critical temperature, but there's no climate change. There's no climate disaster. Europeans are living as if life is going on as normal. If you talk to a climate scientist, they will say, oh, well, Europe is land and the global average is land and ocean. My thinking is, yeah, maybe it's right, but it's a great excuse. Because if you want to say critical temperature, then you have to be specific. Critical temperature in land, critical temperature in ocean. Yes, emission CO2 is due to human activity, because the thinking is that it's human activity that's causing global warming. If you plot the world population, this is from 3 billion to 8 billion, and the emission CO2 in millions of kilotons, you find that the blue dots are the emissions, and the orange dot is a model of that emissions, and the R squared, which is a statistical parameter for regression, which tells you how good the fit is. It's 97%. It's an incredibly good fit. So we know that emission CO2 is due to human activity. In a sense, you could say that this is proof, but bear in mind, correlation is not causation. You have to study this a little bit more. And so what we can say is that, yes, it's very strong suggestion that emission CO2 is due to human activity. I am not taking into account the context of this problem. We're just looking at the data, emission CO2, human population. Why that happens is a sociological and economic problem to be structured in mathematical form to say, for every 1% of CO2, you get so much emissions, and this is the reason why. Here, we are not getting into the interrelationship between emission CO2 and human activity and the type of human activity. We're looking at the broad, high-level picture. So yes, when we're looking at that broad, high-level picture, yes, it is human activity that causes emissions CO2. Are emissions CO2 the cause of global warming? Let's look at this. Again, these are the sources of the information. And we can see that on the bottom x-axis, I have put the emission CO2 in millions of kilotons. And on the y-axis, global temperature anomalies in terms of in centigrade. And you can see that there is a very strong relationship from 1960 as the years go by to 2015. That's a very strong relationship. Here, it's practically a straight line. Okay, but there are two sets of abnormal behavior. I've circled them in red. The first is in the 60s, and what we can see is that the global temperature anomaly actually dropped from 1960 to about 1968, maybe, yeah, 1968. That's what the model shows from the data. Of course, you could say that it's because of noise in the data, granted. And the same with here. You can see that emissions, the blue dots, is moving vertically. But it's not moving horizontally. That means emissions CO2 is not increasing, but the global temperature anomaly is increasing. So these two are abnormal behavior compared to the center portion of the graph. And so these two needs more research. The one way to reduce the noise in the data is to dig deeper in and figure out what else is going on. But at a high level overview, we can see that, yes, there is quite a strong relationship between emissions CO2 and global temperature anomalies. When you look at this data, it's 1968 all the way to 2015. It's linear. So now what we are seeing, when you look closer at the data, what we are seeing is the calendar years also is a hidden factor in explaining the emission CO2. So we have two factors to consider. One is the calendar year, which is a good indicator of human population, and the other one is the actual CO2 emissions. So this graph says, hey, yes, it looks like emission CO2 is a possible cause of the temperature anomaly, but hold on, let's not jump there too fast, because the calendar year is also an important factor to consider. And calendar year is a proxy for population. The big question is, compared to what? You have, if you read the blogs, you will see huge numbers on emission CO2, millions of kilotons, and some people quoted in billions of kilotons, billions of tons. So we are looking at numbers like 10 to the power 9. And if you convert it into kilograms, it's 10 to the power 12 kilograms of emissions carbon dioxide. And so the question is, wow, it's so much. But if you ask the question, compared to what, a different story emerges. Let's look at the background CO2. What is the atmospheric CO2. These are the gases that's present, the major gases that's present. Earth's atmosphere is primarily nitrogen, followed by oxygen and argon. There's more argon in the air than there is CO2. And these are the molecular weights. This is the average molecular weight of the gases in the atmosphere given this composition. And this is the density of the pure gas. So you have to get the density in air, you have to use this ratio to figure out these densities, and then you can convert it into milligrams per meter cube and then convert it into ppm. And you get carbon dioxide ppm is about 338 based on this composition. So it's a good order of magnitude. It's done the correct way. You can check it, and this is the check. It shows us it's correct. So on an order of magnitude basis, nitrogen is on the order of 10 to the power 15 kilotons. Oxygen is on the order of 10 to the power 14 kilotons. Argon is on the order of 10 to the power 13 kilotons. And carbon dioxide is on the order of 10 to the power 12 kilotons. So you can see if you reduce the numbers, if you change the units from kilotons to kilograms, the exponent here goes from 12 all the way to 18. So it's a huge number. Remember that we were working with emissions carbon dioxide of tens of millions. So when we I plotted out best fit models. These are 97, 98, 99% R squared. So there's no issue that these are good indicators of what's going on. So what we have here is the global population on the x-axis, and on the left y-axis, we have emissions CO2 in kilotons, millions of kilotons. On the right y-axis, we have global CO2, atmospheric CO2, also in kilotons, the same units, except that these are in trillions of tons. So it's 10 to the power 12. This is 10 to the power 6. So you can see that as atmospheric CO2 increases, we also see that emission CO2 increases, but their slopes are different. So the reasoning that climate scientists give for saying that emission CO2 is the reason for global warming is that CO2 increase is caused entirely by human activity, which is a correct statement, but it's not complete. And since emissions are at record high, CO2 increase has also been at a record high. Not quite. Yes, they are correlated. You can see that they are both increasing, but the order of magnitude, one is in millions, the other one is in trillions. So that statement is not correct. But from what I can figure, using these two statements, climate scientists have jumped to the conclusion that emission CO2 is the cause of global warming, is the cause of atmospheric CO2 increasing, and therefore the cause of global warming. But there's a 3-order magnitude of difference between the two types of carbon dioxide. One is in millions, the other one is in trillions. So if we say compared to what, let's put it in perspective. You get some shocking comparisons. Here, again, I've plotted the graph. This is by year. The blue dots are emission CO2 in millions. And the orange dots, the gray dots are the atmospheric CO2 in kilotons. I've converted the Mauna Loa ppms into kilotons. And you see the model is the orange dot. It's a very good model. It's practically perfect. And we see that emission CO2 is approximately 0.001% of atmospheric CO2. In 2018, atmospheric CO2 was 408 ppm, 409. Emission CO2, if you convert that kilotons back into ppm, you see that it's actually 0.05 ppm. That's an 88, practically 90,000 times smaller than atmospheric CO2. Emission CO2 is 90,000 times smaller. If you look at the increase, emission CO2 has been increasing by 0.00006 ppm per year, and atmospheric CO2 has been increasing at 1.60 ppm per year. That's a factor of 28,000 times difference. So, do you think, given these numbers, the rate of increase and the actual quantities brought together in a same scale so that you can compare it, do you think that emission CO2 causes climate change? My opinion, the climate change, given this data, the climate change control policies cannot roll back atmospheric CO2 ppm levels. An alternative hypothesis for CO2? Of course, we have to have an alternative hypothesis because CO2 doesn't miraculously appear out of nowhere. Law of conservation of mass and energy is fundamental property of everything in the universe. So where is the CO2 coming from? Okay, so if we plot deforestation, down here is the population in billions. Here is the forest area on the y-axis. We have the forest area in square kilometers, millions of square kilometers. And we see that the blue dots, which are hidden by the orange dots some of the time, is the actual data. And you can see from 1999 all the way to 2015, the forest area of the planet has dropped from about 40 million to about 40.6 million to about 40 million, while that population has increased. And it's a nonlinear function, very slightly nonlinear, which is correct because if you look at the logic of this situation, the more you deforest, the less forests you have to deforest. So the deforestation should slow down. So the data matches the logic. Then if we compare, try switching the factors around a little bit. If we put the forest area in millions of square kilometers on the x-axis and put the emission CO2 in kilotons, millions of kilotons on the y-axis, then we see a very nice fit. You cannot see the blue dots because the purple dots, the gray dots are hiding the blue dots. The blue dots is the actual data, and the polynomial for the model is the gray dots. I left out this last point because this is an outlier. And so you have two problem areas at the end of each of these graphs, just like all the previous graphs I've shown you. One is here in 1989, the emissions CO2 was much higher than for the forest area, and all the other regions, it was spot on. And here, in this region, we have another abnormality. what we're seeing is that even though the forest area is decreasing as you go from right to left, the forest area is decreasing, but the CO2 emissions is flat. So this is a more sophisticated model. Will have to take that into account. But the conclusion is that the relationship between deforestation and emission CO2 is not simple and straightforward, because there are intermediate factors like combustion engines and development of roads and infrastructure that alters this relationship. Okay, the forests are the lungs of our planet. If you grew up in the 60s and 70s, that's what environmentalists would tell you, that the forests are the lungs of our planet. And so we can work out the non-emission CO2 in the atmosphere. It's basically the atmospheric CO2 minus the emission CO2. And so what we do get is an almost perfect fit. The blue dots are non-emissions model, and the orange dots are the Mauna Loa carbon dioxide in ppms. And you can see, because emission CO2 is 0.001% of atmospheric CO2, there's practically no difference you can figure out. So what we can see, what we can show, and down here the x-axis is the forest area in millions of square kilometers. So what we can show is that from the data is that for every 1 million square kilometers forest deforested, atmospheric CO2 increases by 32 parts per million. Think about that. Emissions CO2 is practically zero compared to atmospheric CO2. Atmospheric CO2 is dictated by forest area, and for every million square kilometer of deforestation, the CO2, atmospheric CO2 increases by 32 ppm. So IPCC intergovernmental climate change studies organization, they say that but plants capture only a fraction of the annual CO2 emissions. Not true. We have just shown that 1 million square kilometers is equivalent to 32 ppm. So this statement by NOAA and IPCC scientists, climate change scientists, is false. So can reforestation achieve 300 ppm? Because that's where let's set that as a target, because that's close to what was the 1960s and earlier. For that, we need 4.7 million square kilometers of new forest on this planet. And that area, that 4.7 million square kilometers, is about half the size of the US. That's how much we have to reforest our planet to get our atmospheric CO2 down to 300 ppm. Are there other problems with global climate change thesis? First, let's look at the accuracy of the climate change model. This is the analysis done by Dr. Rudolf Calvex. It was done in 2021, this year, and it's based on sea surface temperatures between 1979 and 2021. That's this year. This black line is the actual data. You can see it's wavy, and I've drawn a red line across it, a thick red line across it, to give you a better visual of the slope of the black line. All these other lines up here are the model simulation results out of 68 simulations from 13 models. You can see that all climate change models give excessive positive bias. That means any policy that's based on the outcome of these climate change models are overkill. Are sea levels rising? Anybody who has lived or visited a beach or lived by the beach or worked at a port for many years will know sea levels have not risen. So the question we must ask us, use common sense. The question we have to ask is, why do climate scientists say that the sea levels have risen by 10 centimeters, this much? This is something anybody can notice. Why do they say that? So let's turn the problem around and we say, okay, climate scientists say that sea levels are going to rise by 1 meter, which is about 3 feet, or 2 meters, which is about 6 feet. That's what's claimed in the mass media, in the public. And they have all these reports that they point to that say all this. So we can calculate the radius, and let's say all that seawater, that rise in seawater, was ice on the land. So how high would that ice be if it covered all the land of the whole planet? So we get, from the change in the radius, we get the volume of water are required. We can convert it into ice, because density of ice is 90% of water. So when you put a block of ice in a glass of water, mark the level, and you let it melt, what happens? The water level does not change, because by Archimedes' principle, the volume of ice displaces its own weight in water. And so this is the land area of the whole planet. And so to increase the sea levels by 1 to 2 meters, we need ice of 3 meters, which is to increase the sea level by 3 feet. We need the entire planet covered by 10 feet, 9 to 10 feet of ice. Do we see that? No. To increase the sea levels by 2 meters, which is about 6 feet, we need 16 meters of ice, height of ice, over all of the land on this planet, which is about 18 to 19 feet. Do we see that? No. So the ice on the land, not snow, ice on the land is not sufficient to raise sea levels. What about the Antarctic? Okay, I did a lot of researching, and I found these were the two numbers that made a lot of sense from reputable websites like the Australian Arctic Program, the government climate website, NOAA, and the Australian government's Antarctica website. And you see that this is, the winter is when the Antarctic ice expands, and then in summer it contracts back. So this is the average size of the Antarctic ice winter, and this 2.5 million square kilometers is the average size of the Antarctic ice in winter, in summer. And these are the two heights, depending on which website, paper you read. Some say it's 1,600 meters average depth of the ice. Some say it's 1,900. There's a report which says that the deepest ice is about 4 kilometers to 5 kilometers, if I remember it, if I recall correctly. And so that most of that ice is below the sea level. So even if it thaws out, it will not raise sea levels. So all we need to do is take the 1,600, 1,900 and convert these two numbers into available ice, and then plug it back into the ocean level, into the oceans, and see what temperatures, what heights the oceans will rise. And if we use the winter maximum, we get 56 to 68 meters rise in sea levels. If we use the summer numbers, it's about 8 to 10 meters. So this translates to about 200 feet, and this translates to between 25 and 30 feet height of the ocean level. But, a very, very big but, ice over water cannot raise sea levels. So when global climate change, global warming climate change scientists claim that the oceans are going to rise by 200 feet, that is a false claim. So yes, maybe if the entire Antarctica melted, you could get between 25 to 30 feet, 8 to 10 meter rise. However, the Australian Antarctic program, they actually make it clear. They do not. These are experts who have spent decades working on this continent. They say, we do not know how ice sheets will respond to global warming. That is the largest unknown. We do not know. So to claim that everything is going to melt is a false claim. And then to claim that it's going to rise to by 200 feet is another false claim. So we look at what, if it was possible, what needs to happen. These are the temperatures recorded at Vostok Station. This is the coldest spot on Earth. So if you want all the Antarctic ice to melt, this ice must rise by at least 14 degrees centigrade or 25 degrees Fahrenheit. The blue lines are temperatures in centigrade, the red lines are temperatures, red numbers are temperatures in Fahrenheit. And you can see from this, looking at this data, you can see for all the ice to melt, the temperature of this point, Vostok Station, must increase by at least 14 degrees centigrade or 25 degrees Fahrenheit. All life on Earth, most of life on Earth, will be dead by then. It's my personal opinion is that is possible. So, summary. Our emissions-based climate change control policies cannot reverse global warming. If you look at the summarized data, this is the emissions CO2 as a ppm. In 1960, it was 0.001. In 2018, it was 0.004. That's entire increase in emissions CO2 between 1960 and 2018 was 0.17 ppm. Not 1, not 5, not 10, but 0.17. Let's round it up. 0.2 ppm over 60 years. And that converts into a rate of increase of 0.000057, rounded up, 6 ppm a year. Atmospheric ppm went from 316.9, let's say 317, to 408, let's say 409 ppm. That's an average increase of 1.6 ppm per year. The magnitude of this difference, the magnitude is this 1.6 is 28,000 times larger than this 0.00006. If you look at these two numbers, the ratio of the emissions to the atmospheric in 2018 was 0.001%. That same ratio in 1960 of emissions to atmospheric was 0.0004%. So emissions control cannot reverse global warming. Only reforestation can do. Then, if you look at the news media, you'll see news saying, hey, there was this flash flood here. Oh, Germany or Holland was flooded. And all that kind of news. That's not due to global warming. That's due to deforestation. People who have studied deforestation will tell you flooding is due to deforestation because without the top plants and trees on top of the soil, it does not slow down the movement of water into rivers. The water from the rains just pours through. There's nothing to stop it, to slow it down. It just pours through and becomes a flood. So reforestation is deforestation is the cause of flash floods, not global warming. Conclusion, IPCC, climate scientists fooled all of us, including myself. Thank you.